Hi, in this video I'm going to speak a little bit in English because I must train the language. And so it is to find the radials in the domain of convergence of the power series, which is written over here where n begins to 1 to infinity, and I will have 1 over square root of n times 2 times x minus 1 to n. And I must, to find the radial, I must change a little bit this expression. When I have a power series, it is something like this. You see, let us see, and let us say that n begins at p to infinity, and I will have over here, let us say, a sequence. Let us say a index n, and I have x minus the center, let us say c, to n. As you can see, x over here only have a friend. Let us say the friend, it is the number 1. And here the friend, it is the number 2. It cannot be, you see, because I must express this in this form. I must express this series, this power series, this is the general term, let us say like this, of this power series in this way. So what can I do for this? I think it is quite simple. Let us say, if I have the sum where n begins at 1 to infinity of 1 over square root of n, I can put the number 2 in evidence, okay? Let us do that. 2 times x minus 1 over 2. And all over this to n, okay? And so it is very simple to understand, I think, that n begins at 1 to infinity of 1 over square root of n, 2 to n, x minus 1 over 2 to n. And now it is okay. So now it is okay because, as you can see, I have here my sequence, you see, and the center, it is let us say c equals 1/2. So to calculate the radius, I think it is quite simple, because now it is the limit when n approaches to plus infinite of 2 to n over square root of n over 2 to n plus 1 over square root of n plus 1. So the limit, it will come the limit when n approaches plus infinite of, let us say, 2 to n square root of n plus 1 over 2 to n plus 1. I can make this like this, 2 to n times 2 times square root of n. And I can cancel, of course, I can cancel 2 to n, 2 to n. And this limit, I think it is quite simple to understand, it is 1, okay? So the limit, this limit over here, you see, it is 1. So the limit, it will be 1 over 2. So now I know the radius. I know the radius and I know the center. The center, it is 1/2. I have 1/2 for this side, okay? So it will come 1/2 plus 1/2. It will be 1. And for this side over here, it will be 1/2 minus 1/2. It is 0. So now I have the convergence interval. And the convergence interval, it is the open set from 0 to 1. And now I must make the test to these points over here, which they are 0 and 1. Let us try first at x equals 0. Okay, and now I'm going to this one series over here because I think it is more easier. When x equals 0, it is quite simple to understand that you come this series, numerical series, where n begins at 1 to plus infinite of, let us see, 1 over square root of n times minus 1 over 2n, excuse myself. And this is an alternative series, as you can see. If I take the absolute value of this series, as you can see, it would come this one series where n begins at 1 to infinity of 1 over square root of n, which is the same as to say that it is the series where n begins at 1 to plus infinite of 1 over n exponent 1 half. And this is series, as you know, it is divergent. So now I must apply, of course, to the Leibniz criterion. And so, first of all, I must show that 1 over square root of n is positive, of course it is, because n belongs to the set of the natural numbers. Quite simple to understand. And now I'm going to find the limit, you see, when n approaches plus infinite of 1 over square root of n, and this limit it equals 0. And now I'm going to show, and I think it is very easy to understand, that 1 over square root of n plus 1 is lesser than 1 square root of n. Then the three conditions are satisfied, and so I can say that at the point x equals 0, this series converges, but it is a sample convergence. It is not an absolute convergence, because the series of the modulus, let us say like this, does not converge. So now I can close the interval at the point x equals 0. Now I'm going to make the test at x. Let us put here another color. Maybe I have not the orange color I would like to have, because yesterday Holland did win so well to Spain. I have not. Let us suppose that this one color it is the orange color, okay? And so it will be at x equals 1, okay? And so the series, it will come where n begins at 1 to plus infinite, and I'm going to substitute x by 1, and if I do that, it will come 2 minus 1, it is 1, 2n it is 1, so it is quite simple to understand that in the series the general term it is 1 over square root of n, and this series diverges. So I can say now that in this moment the domain of convergence, it is the interval I must close at the point x equals 0, and I must open at the point x equals 1. Also, I must say that the point x equals 0, the series converge, but in a sample, it is a sample convergence. But in the open interval 0 to 1, the convergence, it is absolute convergence. I hope I tried to make this video a little bit funny, and I hope that you did understand. You must be careful. You see, when x have some number close to him which is not the number 1, and to find the radius you must put the number over here in evidence. Okay, so by now it is all, and I hope that you will have a wonderful day, because today it is a very, very sunshine day. Bye bye, my friends.